Okay, it's been 30 minutes. I have been collecting filtrate. I've monitored my top pressure assembly. It's staying right at the 600 psi that I put into it. My back pressure receiver is about 100, a little over 100, about 104, something like that. So that's certainly well within tolerances. So I'm going to collect one last little bit of filtrate. Basically, what I did during the test, and I didn't have this recorded, but at the 7.5 minute mark, I collected 7 milliliters of filtrate. I'm going to collect the last little bit and see what comes out here. Not very much. So I have right at a total of 11 milliliters of filtrate. So my HTHP value would be 11 milliliters times 2. It would be 22. So the spurt loss we'll calculate in a minute. But at the conclusion of the test, the first thing I want to do, and this is very important, is I want to seal off the cell. And I do that by closing the valve stems. So I'm going to close the valve stem on the top. This will keep any pressure from going into the cell. I'm going to do the same thing on the bottom, being mindful that this is in reverse. So I'm going to tighten. Alrighty. So now the cell is sealed off. So the next thing I do is I want to stop pressure from going into the regulator assembly. I close off the flow of the gas, if you will. So I do that by loosening the T-screw. And when I do that, I'm depressing the pressure on the diaphragm, and the diaphragm is popping back into place. And when this gets loose, as it is here, there is no pressure coming from the CO2 bulb through the regulator. It's being stopped by the diaphragm. So I will do the same thing on my receiver regulator. These regulators, by the way, are both Concoa regulators. They take the same diaphragm. They take the same regulator repair kit, which is a part number 14307. Okay, so I have this completely backed off and this completely backed off. So I have no pressure going into either of the regulators, or actually going through either of the regulators, because the diaphragm is stopping the gas from flowing past it. However, I do still have pressure between the regulator and the cell, and in the cell, as a matter of fact. So the pressure in the cell is sealed off by the valve stem, but I do have some pressure here, and I've got some pressure between the regulator and the receiver body. So in order to alleviate that pressure, I open the safety bleeder valves. These safety bleeder valves have a dual function. They alleviate pressure at the end of the test, but they also prevent you from overpressurizing. They're preset to blow off at about 190 psi, which, if you're using a full bottle pressure with nitrogen tank, you could put 3,000 psi in there. So these are safety features. It bleeds off the pressure, but additionally, they're safety features and they don't allow too much pressure to be put into the assembly. So I'm going to bleed off the pressure. You see the gauge go down to 0. So now I have no pressure going in here at all. I'm going to do the same thing on the outlet side. I want to be careful not to burn myself because this is hot. I will bleed off the pressure there. So both of these assemblies now, there's no pressure going into my valve stem assembly. I can now remove the pressuring assemblies from the top and the bottom. I do that by unhooking the lanyard. And again, paying attention, this is hot, so I have to be very careful. So I take my top pressure assembly off. I remove the cotter pin, take my retainer pin off the bottom, and remove my back pressure assembly on the bottom. So now I have my setup that is still in the heating jacket, and I still have 600 psi into the filter press. So what I want to do is drain any residual pressure that I have in the in the receiver tube, which probably won't be very much because I'm not collecting a lot of filtrate, but sometimes you do collect. Yeah, there's a couple of drops in there that came out, but only a couple of drops. It didn't really change anything. I'm still right at 11 milliliters of filtrate collected. So I've got my system is sealed off. I have a hot heating jacket. I can turn the temperature off on my filter press heating jacket and remove the cell from the heating jacket. I do this with the cell removal tool. You can do this with pliers, with a wrench, but that is dangerous. You run the risk of dropping it on your foot. With this device, it works like a champ. I don't really need to hook the lanyard. I'm going to pick this up and take it from here to the sink. The API says don't cool down a cell with water because it's dangerous, because the steam can burn you and it weakens the metal in the cell cap and cell body over a period of time. Pretty much everybody waters these down to cool them up. The water works very well. It cools them in less than 5 minutes. So I'd recommend go ahead and using water, but be very careful when you pick this up. I'm going to put my filter press cell body in the sink, and I'm going to run cold water over it until this stays warm. This cools up. I'm going to maintain this in an upright position because I have my filter cake on the bottom. And I will place this in the sink and let it cool down with water. And I'm going to turn the video off and come back and we'll do the cell disassembly in a few minutes.